Okay. Chapter 1, Fluid Power Systems and Industry. You golf drop?
Yeah, you got one.
Okay, hopefully by the time we get done with this chapter, we'll be able to describe how fluid power is used in modern applications. List and describe common safety hazards when working around and on fluid power systems. List and describe common fluid power safety practices and related training programs. List the different fluid power industry associations and their certifications. Exposed fluid power system takes shape of the container that occupies and exerts pressure equally in all directions. So basically what that's saying is when you enclose any kind of fluid, whether it be air or just air is considered fluid. So air, oil, water, acid, whatever the fluid is, when you contain it and you exert a force on it, it creates pressure in it. And because of Pascal's law, not because of, but Pascal's law tells us that that pressure is exerted equally in all directions through the fluid. Okay. Modern fluid power applications, they are present in applications such as elevators, hydraulic cranes, aerial lifts, industrial robots, construction equipment, and forestry equipment. I'm not familiar with fluid power being used in wind turbines. Those are all mechanical gearing, but I could be wrong. The elevator in this building is operated on hydraulic power pressure. So you ever get in, push the button for the first time in the day, you go whoosh before it takes off. Kind of makes you. Fortunately, if you're on the bottom floor, you can't fall any farther because it's lowest possible point. I imagine you go a little bit, not much. Got something in my eye beside my finger. Anytime you're talking about hydraulics especially, that's where safety really comes into play, because you can develop a pinhole in a hose in hydraulic system, and some of those run 5,000 to 6,000 pounds per square inch, which is like having an elephant standing on your chest. Comes out of that hose at really, really high speed. And have you guys ever seen a water jet operate like on YouTube or in person?
It's kind of like if somebody sprays somebody with a fire hose.
Well, that's just going to knock you down. If you have never seen a water jet do its thing, you can take 2-inch solid steel and cut it like it's butter with water. Granted, there are some particulates in there that are abrasive, but still it's primarily the water pressure that's doing the cutting. Protective helmet, 2 types. 1, impacts from the top. 2, impacts from the top and the side. Protective helmets are used in workplace to prevent injury from impact, falling, flying objects, and electrical shock. Depends on the helmet, on whether it will protect against it says Class G is general service, which offers limited voltage protection. It is up to 2,000 volts. E is utility service, high voltage protection, think E electricity. That goes up to 20,000 volts. And then C is a special service where it offers no protection against voltage at all. So, you're going to be very careful.
What do they use to protect against electricity, for example? Is it like a rubber?
It's just the material that the helmet's made out of. The fiberglass offers pretty decent insulating properties against electricity. Rubber, of course, rubber is be hard rubber or soft rubber. You have a soft rubber helmet is not going to make much of a helmet.
Yeah.
But yeah, there are certain things that offer really good protection against it. And the reason why is because it's very high resistance. That adjustable headband, crown straps, lining, all that stuff goes up inside the helmet. That is what actually goes on your head. And there's an air gap between that strap and the top of the helmet, so when something hits it, the helmet itself doesn't hit you in the head. Okay. Eye protection must be worn to prevent injury to the eyes or face from flying particles, molten metal, liquid chemicals, chemical gases, radiant energy, or a combination of these hazards. So, at the very least, if you happen to wear eyeglasses, they need to be safety rated lenses, and then you can get side shields to go on. Sometimes the side shields are already built in, especially if it's a prescription safety glass. The goggles go around your eyes, just protects your eyes, and then face shield protects your whole face. Usually they come down far enough to protect your neck too. Emergency eye wash and shower equipment. Eye wash station allows quick flushing of contaminants from eyes after accidental exposure or your whole body if you happen to be standing under the shower. We do have a couple of safety shower and eye wash stations out here in High Bay. The only thing out there that I know of that you would need to use the shower for would be when we're doing the hydraulics, if the line happens to rupture. But we're not going to have them on long enough for the oil to get there, so you don't have to worry about getting burned by it or anything. It's just really messy. Okay. When we are working on hydraulics, especially eye protection will be required. If that stuff gets in your eyes, you're going to know it. You're not going to be happy. Hand protection, neoprene gloves can provide hand protection from hydraulic oil and a variety of chemicals and acids. Not all gloves are created equal. So when you are dealing with any chemicals, pay very close attention to the safety data sheet that comes with it, so you know what your proper PPE is, personal protective equipment. At a bare minimum, probably 95% of everything out there says safety glasses and gloves. The other 5% is at least safety glasses. And then many things require a rubber coat, special kind of glove, full face shield instead of just safety glasses, all kinds of stuff like that. Hearing protection devices reduce the level of noise reaching the eardrum. Usually, regular earplug only attenuates just a few decibels. Earmuffs do more, And if you use them in combination with each other, both of them at the same time, it really knocks down the noise level. You ever see people out on tarmac at the airport? They've always got the earmuffs on. They've got earplugs under them too. When the jets take off, it's like 130 dB, which will make your eardrums bleed like that. When OSHA is talking about acceptable noise levels and whatnot, it's a weighted average over usually 8 hours because of a typical work day. You're standing behind a jet engine when the plane takes off. The weighted average is 0. It is instant, you're deaf. I have actually
Stand behind the jet.
Well, if you're standing behind the jet, not only do you go deaf, but it also blows you back 100 yards. You guys ever watch Mythbusters when it was on?
Oh, yeah. Great show.
Did you see the episode where they pulled the bus along behind the jet and it blew the bus over? They picked it up, tossed it like it was a matchbox.
Which, do you remember what model of jet, fighter jet they used?
It wasn't fighter, it was just commercial. It was a little one, like 737. And, yeah, but it was a full-size city bus. Unloaded, of course. Foot protection, safety shoes protects against falling objects and have soles that are not affected by hydraulic oil. I have, see if I can do this. Those are steel toes.
You got those at Walmart, didn't you?
Mm-hmm.
I got those exact same steel toes.
Yeah, steel toe, and it's got the neoprene sole on it so that it's not affected by hydraulic oil. Safety shoes are not required in the high bay, but they are definitely encouraged. Because if you happen to drop any of the stuff on your foot whenever you're out there working and you're not wearing safety shoes, you're gonna be jumping down, up and down and inventing new curse words and all kinds of stuff. And then we gotta fill out all kinds of paperwork and safety and security get involved, and yeah, it's not pretty, so. The moral of that story is either wear safety shoes or just don't drop shit on your toes. Lockout, tagout. Lockouts and tagouts are applied to power sources to prevent equipment operation during inspection, maintenance, and repair. You can, under very specific circumstances, use a tagout without a lockout. I say that those are very specific circumstances. You cannot, under any circumstances, use a lockout without a tagout. Okay, you put a lock on there, you need to fill out the paperwork and do the tag that explains why that particular power source is locked out. Okay. You also need to remember that power sources include electricity, which everybody's pretty aware of, but it's also hydraulic pressure, pneumatic pressure, gravitational potential energy. There's a whole bunch of things, thermal, lots and lots of things that you need to worry about when you're trying to isolate a machine. Gravitational potential energy is, think of a punch press where the ram is sitting up in the air. If for whatever reason happens to become detached or the flywheel brake gives way, gravity's going to pull it down. Okay. This is a truncated version of the procedure. Notify all personnel affected. You guys are going to have to learn and remember what is affected, what is authorized, and so on. Stop equipment and remove all power sources, release any stored electrical energy, and or pressurized fluid. Secure moving parts as required, which we put a block in to keep shit from falling. Apply the lockout, tag out, measure for voltage using voltmeter, test all controls to, to ensure the power is off, and verify all controls are in the off position. The full list of 7 steps is in the book. After working on equipment, remove tools, release security removing parts, prepare for equipment operation, make sure all affected personnel are clear of equipment, replace all safety guards and controls, remove lockout, tag out, re-energize and test. This multiple lockout hasp is used whenever multiple people are working on a piece of equipment. Everybody has to put their own lock on. There are only 2 people on the face of the planet that are allowed to take your lock off. That is you and your direct supervisor in the event that you die before you get a chance to take it off. Anybody else at any other time, they can be held personally liable should anybody get hurt because of removing a lock that they were not supposed to. And by personally liable, I mean you can face up to very hefty financial fines, possible imprisonment. OSHA does not mess around when it comes to safety. That's their whole purpose, their occupational safety and health administration. Fluid power industry trade associations. There's a number of fluid power industry trade associations that offer certification to mechanics, technicians, and other specialists in the fluid power industry. They are the FPDA, FPEF, FPSI, IFPS, and NFPA. That says NFPA.com. There's also an NFPA.org, which is the National Fire Protection Association.
I've heard of that one.
Now, most people think NFPA, they think National Fire Protection rather than fluid power. Now, professional fluid power industry certifications. Various certifications are available for fluid power technicians. There are 3 levels: mechanic, technician, and specialist. Mechanic is usually somebody that is affectionately referred to as a wrench slinger. Their job is to work on mechanical things. Technician is more of a controls type person where you're worried about electricity and fluid power and that sort of thing. And a specialist is somebody that specializes in a particular area. You know, you can know a little bit about a lot of things, but do you know everything about one thing? There aren't too many people that do. Okay. And that is the end of that. So, anyway, the hydraulic pressures can be, several thousand pounds, excuse me, per square inch, which means that for every that's about a square inch. How long do you think that board would survive if I put 5,000 pounds on it? Matthew?
Not very long, like seconds.
Probably not very long. Okay. So, what if instead of that,
The pressure probably would be extremely abrasive to meat, like it will just cut right through it instantly. It'll be instantaneous, it'll be 0 seconds that'll last.
It poke hole in that pretty effectively.
Yes.
When you are inspecting your hydraulic system, a lot of people run their handle on hoses, check for leaks, which is great because if you get hydraulic fluid on your hand, you probably don't notice it. But when you do that, you want to make absolutely certain that the system is not pressurized. Because if there is a pinhole in that hose, when you run your hand past it, that's several thousand pounds per square inch. Guess what it's going to do?
Cut your finger off.
It cuts fingers off. In a hurry. And there are documented cases where people have done that. And it goes right through your flesh, right through your bones, flesh it. And really, really short order. So, Sage.
I have a question. So, if it were to, whenever the machine or whatever is pressure, like a hole gets through it, it starts spewing out. The machine is in operation when it does it. What would be the safest and best way to get it off? Or would you just get out of the way?
Well, if you happen to be in direct line of sight for that hole, you're getting wet. Fortunately, if you are around a machine that is operating under those kind of pressures, there will be guarding in place that won't allow you to get close enough to it for it to hurt you. But you'll absolutely want to shut it off. One, if the oil is leaking out of the system, it won't take very long with those kind of pressures to empty the reservoir, and then you end up cavitating your pump and destroying it, and then it just bad all the way around. So, most places have some sort of preventative maintenance schedule where you take the guarding off and you inspect all the fittings and hoses, look for dry rotting and obvious wear. If a hose is running on the same place over and over and over and over again, it's going to break no matter what. Those are the kind of things you want to keep an eye out for. Hopefully, you can catch a potential failure like that before it happens.
We had a forklift that it started leaking. I don't know if they hit it against it or whatnot, but it just started leaking just everywhere. Kind of waited for it to stop. I really do. There's a protocol.
Yeah. That's why every machine has an oh shit button. That's what you say before you get it. Matthew?
Any stop button should come in handy in case something catastrophic happens. If it's like catastrophically goes wrong, you want to hit that like.
Yeah, that is the very definition of an e-stop, is the emergency. If something if something catastrophically fails, it is stop it right now.
Oh shit, well.
Yeah.
That's a good one. So,
That's
that
the
basically
best you
means
say it,
catastrophic.
then you do it.
You got to have oh shit bars too, you know.
Yeah.
Yeah.
Many different kinds. You have the cable, full cable. There's a roll former down here in PMT area.
Yeah.
And it's got the cable around it. So if you hit that cable at any point, it pulls the contacts open on the e-stop switch. And then it won't restart again until you go over and manually reset it. That is something else that defines what an emergency stop is. It has to be locked in position when it's actuated. required.
So is that the shop down here we're gonna be doing all that in?
No.
No, okay. I saw that one, I was doing the walkthrough yesterday. It's my first time in OTC, so like I've never, it's a
Yeah,
lot bigger than the high school.
that area down there is leased by Detroit Tool out of Lebanon.
Okay,
Our area is right outside the lab here,
okay,
and then Precision Machining is down Canyon.
okay, okay.
Okay, so, lockout. Cannot be done without a tag out. Tag out may be done without a lockout in very specific circumstances. Basically, the rule says that if it is not physically possible to lock out an energy source, that is the only time that you're allowed to tag out. Okay. But people being creative have come up with some really cool ways to lock things out. That, you know, how in the world are they going to lock that out? Well, it may be something as simple as wrap a chain around it so you can't move it.
We started doing at work to where if you open a door, it'll have a little metal piece that comes
Can't reclose it.
in.
You know, presumably those doors would be, have an interlock switch on it that breaks the safety circuit and shuts it down anyway. Safety includes a lot of things. You got the area scanners and the light curtains and pressure mats and pull switches and e-stop buttons, and they make safety switches that go on the hinges of doors. So as soon as you start to crack it open, the hinge is going to move, right? That becomes the safety switch. Many of them are interlocked so that you cannot even open the door until you have shut the machine off. So, you know, lots and lots of different ways to do it. The one we need to really concern ourselves with, though, is the fact that hydraulic systems run at such high pressures. You know, you can easily cut off fingers or a hand, or, you know, at the very least, anybody in here Star Trek fan? Star Trek?
The older the view.
Any?
I've been there, started that.
Yeah. You ever see the doctor use the hypo spray?
Mm-hmm.
Those actually exist.
What? Nah. What do we ever see with now in society?
Yeah, those actually exist.
Oh, man.
But you can do the same thing with an airline out here in the shop, or you can especially do it with hydraulic line. However, if you inject yourself with air, you can vapor lock your heart and drop like a stone. It's called cardiac arrest. If you inject yourself with hydraulic fluid, that's also a bad day because it can very quickly become infected. It can damage tissue to the point where it actually starts to rot and fall away, where you have to go and, you know, potentially have limbs amputated and all kinds of bad things. If you haven't already amputated it yourself by running your finger over that pinhole at 5,000 psi. So, the point that I'm trying to get across is safety when dealing with fluid power systems is a really, 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 really big deal. You know, not only can you get hurt, but it can also be fatal. And, you know, everybody in this room, I'm sure, would like to go home with the same number of appendages that they got here with. Anybody have any questions on that? The,
You have a question?
yes,
It's related to workplace. So when you use lockout, tagout, are all employees required to be able to put one on the machine?
no,
No. Is it just the technicians, the people who actually interact with machines?
it's what is known as an authorized employee. In order to do lockout, tagout, you have to be trained and tested for knowing the proper procedures and that sort of thing.
Doesn't necessarily have to be like a maintenance individual or the person running that machine, as long as they're certified or.
As long as they're trained properly and authorized.
Is there a time limit with how long you can have the lockout, tagout on there? I mean, there could potentially be machines that sit there for weeks untouched.
Yeah, it all depends on what's wrong. You know, if you lock it out because a shaft broke or whatever, and you have to wait for one to be manufactured, or, you know, it coming from somewhere overseas and, you know, has to be manufactured there, and then it has to go through customs, and, you know, they put it on the slow boat instead of the fast boat, and, you know, there are any number of reasons why the machine would be down for multiple days at a time. If it was because a fuse blew, probably not going to be days. But, you know, it depends on what caused that fuse to blow to.
Does OSHA make their own lockout, tagout devices to give companies or is that?
It's all third party. Brady makes vast majority of